Exercise 32, page 64, question number 1, solve this equation. Again, I'm going to leave you to the one in the textbook, but I'm going to have a look at one very similar. And this one underneath is what we're going to look at. This equation has fractions involved with it. 3x divided by 2, there's a fraction. Note this 5 over 2x, or 3 over 4y, or 2 over 3y, 3x over 2, they are actually the same thing. I can write 3x over 2, all divided by 2, is equivalent to, is exactly the same as 3 over 2 times x. So they are equivalent, don't let that put you off. Remember, I think we've mentioned this already, that a over x divided by x, a number divided by another number, is exactly the same as a multiplied by 1 over x. Dividing by a number is the same as multiplying by 1 over it. So they are actually two ways of saying exactly the same thing. The bottom line is that we're dividing by 2 here, we're dividing by 2 here, and we're dividing by 4 there. And what I want to do is to get rid of those numbers underneath those fractions. If I were to multiply this fraction here by 2, they would cancel. So multiplying by 2 is a good idea because that gets rid of that 2 underneath there. Of course, if I multiply by 2, every term on both sides has to be multiplied by 2. So actually that will also get rid of this 2, wouldn't it? Okay? But not the 4, because I'd still be left with a number underneath. So sometimes it's worth pausing for a minute and see if you can think of a number that goes into all of these, and that would be a 4. So if I were to multiply through by 4, I'd get rid of all the fractions in one hit. However, that doesn't really matter. I could multiply through by 2 first, get rid of some of it, and then multiply by a number, another number, and so on until I've got rid of all the fractions underneath. So let's have a look at it and see what we're going to do. I'm going to multiply both sides of this equation actually by 2. So each term has to be multiplied by 2, which would mean I'd get 8 plus 3x divided by 2 multiplied by 2, got rid of the 2, equals 2 times 5 is 10, plus, again I've got rid of the 2 there, so it's just 5x, plus 3 times 2 is 6 over 4. Just pause a minute and see if you can see how that's arrived at. In this particular one, I've taken the 3 over the 4 and multiplied by 2. So 3 times 2 is 6 over 4. This is like 3 over 4 times 2 over 1. So multiplying out the fractions, I get 6 over 4. Now, I want to get rid of this 4, so multiply both sides of the equation by 4. Multiply every term by 4. And that will get rid of that 4 underneath. So 4 times 8 is 32. 4 times 3 is 12. 4 times 10 is 40. 4 times 5 is 20. And then the 4's gone here. So I'm left with that. Now I've got an equation to solve very similar to some of the questions you're doing in the previous exercise, exercise 31. I've got rid of the fraction element by multiplying through by a number. So multiply through by 2 gets rid of that. Multiplying through by 4 gets rid of that. Going back to the original question here, I could, back to the original example, let's just try what would happen if I multiply through by 4. I multiply every term by 4. That will get rid of the 2's and the 4 here, but would still leave us an equation to solve very similar to the one that we've already looked at. So if I multiply through by 4, I get 4 times 4 is 16. 4 at the top here means that if I then can cancel, 2's goes into 4 twice, So that leaves me 2 times 3 is 6x equals 4 times 5 is 20 plus, again, multiplying through by 4 leaves me 2 on the top, so 2 times 5 is 10x plus 3. Now, if you look at that, we can solve straight away. I've got rid of all the fractions. And comparing this one with the one that we had here, if I were to divide each term by 2, I'd end up with the same equation that I've got here. So I've got to the same state, but I've done it slightly quicker by looking for a number that actually goes into all of these denominators. But we get this to the same place in the end. So see if you can finish that off now. You can check that you've got it right by putting the value of x when you've solved it back into here and seeing if it works, and then have a go at the question in the textbook.